Hi guys, welcome to my series on machine learning in Theano. In this tutorial, I will teach you guys about how to write a simple regression in Theano. So we'll need to import Theano, tensor.st. Then we need to import some important functions from scikit-learn. Make regression with function. That function will help us generate some random data. Then we'll need to import model selections trained split function, which will help us to split our data into train and test it. Then we need to import the metrics which we will use to evaluate how well our model is performing. And we'll also need to import numpy as np. So first of all, let's generate some random data. So I'll call it features and values, and I will call my make regression function. I can specify the number of samples which I want, and I can add some random noise to it. Then we can split this data generated from this function call into my test and train set. So we can use train test split, pass these two values, specify the size of our test set. So let's use 40% data as our test set. Then we will need to define some placeholders in our Theano computational graph, which will be our data for training. So I'm defining a floating point matrix and a floating point vector x and y. So x will contain my features for each of my samples, and y will contain my regression values which I wanted to predict for each of these features of each of these samples. Let's define two variables, uh, winit and binit, which will contain some initial values of my weights. Call it winit, and let's define the initial values of my bias term to be 0. Let's define some shared variables w and b, and let's assign their initial values. You can specify b in it. Let's define our hypothesis function, which in case of linear regression is simply the dot product between my feature vector, my w, and the addition with the bias term. Let's define the function for my cost, which is nothing but the squared error between my prediction and the true values. So it will be the squared error between my prediction and my true value, which is y. Let's add some regularization, the w parameter, and let's define our gradients. So t dot grad of the cost with respect to w, b dot grad of my cost with respect to b. The final thing which we need to do is define our training operations. So let's define two functions for training and prediction. Let's specify the inputs, that will be x and y in our case. Let's specify the outputs, that will be the cost. Let's define updates operation which we want to do. So since we have two parameters, we want to define two tuples. We want to update our w parameter with the gradient of w, and we want to update our bias parameter with the bias of the gradient of the bias term. The third thing which we need to do is allow input downcast and specify its value to be true. Similarly, we need to define another function for prediction. So let's say it's prediction.op, and it will be a Theano function. The inputs will be x, and the output will be simply the value which comes from my hypothesis. Let's define the training loop. Let's take 100 iterations, and let's train it set. So I'll pass x train and y train for training. Once the model is trained, we can compute the R2 scores. We can pass the true value. Let's compute the R2 score for the train set, and we can compute the value which is predicted from the model. Similarly, we can do it for the test set. We can pass the true value, and we can pass the value predicted from the model. Let's just add this parameter also to the train operation for consistency. Okay, let's run this function. As you can see, the model is trained on the data, and it's giving a very high values for both the train and the test set, which is 0.97. Generally, if the value of R2 score is near 1, we say that the model is able to learn from the features and able to predict. So this was my tutorial on linear regression. In the next tutorial, I will talk about logistic regression. Till that time, take care. Bye bye.